All right, welcome to our talk on managing Kubernetes with Cluster API and Cluster Stacks. We have the great slot after the lunch break, so which one of you feels tired right now? Who actually came here to sleep? No, of course, no one. Okay, that worked great. Wrong button. Now we are back on track. Okay. So I'm Yannis. I'm the co-founder of SciSelf. We at SciSelf, we manage Kubernetes. We have our own commercial product there, and we also have some open source projects. And today's talk is going to be one of our open source projects called Cluster Stacks.
Hey everyone, I am Aniruddha. I am from India and I study at University of Kaiserslautern as well as I work for the SciSelf as a cloud engineer. And on free time, I contribute to Cluster API and its providers. So far I have contributed to almost 5 provider implementations. So any one of you have contributed to more providers, just reach out to me after the talk. And I love hikes and yep.
Okay, short question. How many of you know Cluster API? Okay, almost everyone. That's good. Cool. So great start. First of all, thanks to the Sovereign Cloud Stack. The Sovereign Cloud Stack is a project managed by the Open Source Business Alliance. That's a German NGO. It has received funding from the German government, from the Federal Ministry of Economic Affairs and Climate Action. And the Sovereign Cloud Stack announced some public tenders, one of them being Kubernetes as a service tender. That's the one we won, and today's project talk is about that project called Cluster Stacks. Okay, so first of all, where are we at? Most people that want to have Kubernetes go for a managed Kubernetes offering. They are like really big ones, for example, from AWS. There are small ones like ours. But today's talk is going to be about do-it-yourself Kubernetes. So we're going to be on the right-hand side there. So there are lots of projects which facilitate you like to do Kubernetes yourself. One of them being the Cluster API. That's the one we're going to focus on today because we think it's really good to manage Kubernetes in a declarative way. So all of you know it, so I don't have to introduce it anymore. So why do we need the cluster stacks on top of the Cluster API or next to it? When we want to build a Kubernetes as a service solution, there are lots of tasks that you need to do. There is like, for example, a cluster consists of a lot of configuration. You have like the Kubernetes configuration, you have node images, you have the applications in your cluster, a lot of configuration that you need to do it in the first place, build it up, you need to test it, you need to package it, you need to version it, you need to ship it to your users. So a lot of these tasks have to be done. Cluster API focuses on the lifecycle. So that's what Cluster API does. Cluster API does a great job in it, but also Cluster API doesn't do more than that. It has a very specific scope, and it doesn't go beyond it. It doesn't have to. But we want to build a Kubernetes platform, a whole Kubernetes platform, so we need to think also about the rest. And that's why we came up with the cluster stack idea. So the cluster stack idea is a framework that kind of facilitates you all of these tasks that you have there and that you need to somehow solve. So that's what the cluster stacks are supposed to do. So what are the cluster stacks? The cluster stack has certain goals. On the left-hand side, you see the operations. On the operations side, we want it to be user-friendly. So users are supposed to create clusters on with one click, maybe really easy. They want to update them as well. Obviously, that's supposed to be very easy. On top, they are supposed to be scalable. The operations, it shouldn't matter so much whether we have 10 clusters or 100 clusters. The clusters should be reproducible. So if the clusters always look slightly different, then things will turn out to be very weird because you never know how exactly your cluster looks like, what you have to do, how can you fix things. So we want it to be reproducible. On the cluster side, the clusters are supposed to be ready to use. That's a very important point because like I'm one of the maintainer of the cluster API provider Hetzner. There are lots of people that write issues there. Hey, my cluster is not working. Our standard response is you need to install the Cloud Controller Manager and the Container Network Interface, like 2 applications that have to be installed in the cluster, otherwise it's not working. So like we need to think about the applications in this framework. It's supposed to be production ready. Like, what do you have to do for production readiness? First of all, you need production-ready node images on the base layer. Our framework is supposed to be provider independent. Some providers might provide you with really good node images, others might not. So we need to think about node images as well. The third point is reliability. Like when we create clusters, when we upgrade clusters, obviously we want this to be reliable. So we don't want to kind of destroy like our cluster by doing an upgrade. So this is what we have as, or formulated as goals for this framework. So how does it look like more concretely? First of all, the name cluster stack. It comes from a stack of components for our cluster. So essentially, it's like a bundling or like a bundle of configuration. That's on the left-hand side. On the right-hand side, we have some tools because obviously we want to use these stacks of configuration. We want to build and test these stacks of configuration. So that's why we have certain tools in order to manage this. Okay, so let's have a look, a closer look at this configuration. So we bundle the configuration together. That's like one of the core principles. Because if we put all of this configuration together in one place, we can test it and we can make sure that it works. Like even, we're going to come further to that. Like here you see a V1 and a V2 of the same thing. So we are going to version it and increase these versions. But like, which components do we have? Like which layers do we have in the cluster stacks? So the bottom one are the node images. I just mentioned why we need to think about them. The second one is the Kubernetes configuration. The Kubernetes configuration is like pretty much everything that you usually do also with the cluster API. So like, I mean, you know cluster API, so you know that in like core cluster API, you have lots of YAML files in theory that you need to kind of like configure and then also bring to your management cluster. So that's what goes into the management cluster. And the third one are the cluster add-ons. I don't know whether you know that term. It's pretty much the very important applications that you have in every cluster. So for example, the two I mentioned was Cloud Controller Manager and Container Networking Interface. So these cluster add-ons have to go into every cluster. Now I mentioned that we have certain tooling which you can use in order to like get this cluster stack into your cluster, into like usage. So we have an operator, and this operator has the 3 tasks of first building the node images. Like obviously, building node images might be dependent on your provider. So this is something like we use like the typical cluster API pattern where you have provider integrations. So we have the same thing. So this is like the node images. They are supposed to be provided to you as a user. The second one is the Kubernetes configuration. This is what has to go into the management cluster of Kubernetes. This is also what our software, what our Kubernetes operator does. The third layer are the cluster add-ons. They have to go into every workload cluster. So if you have like one management cluster and n workload clusters, you need these cluster add-ons in all of them. So this is also covered by our software. So we have like the following development cycle. So I said we have a cluster stack, which is a bundle of configuration. It's just like a lot of configuration, and it completely defines your cluster. Like that idea is really important because like this configuration is supposed to kind of from A to Z describe how your cluster looks like. And then you're supposed to create clusters based on this configuration, and you get clusters that 100% look like that. So there we come back to this reproducibility. Hard word. Okay, so we have this cluster stack. We need to build it first. So we have a lot of configuration. We need to build this configuration. Then, second, we need to test it. So we need to test this configuration in order to make sure that it works. And now we come to the interesting part. We release it and we give it a version. Once we release it and give it a version, we can also like ship it to customers. We also have the tooling ready that it kind of gets automatically shipped to all of our customers at the same time, or users, like however you want to call them. And then you might have a version 1 of this, and then you can get a version 2 as well. And then, like obviously, because it's like the whole stack, whole bundle of configuration, you can perfectly test the upgrade as well. Like you have the version 1 before, now you want to build a version 2, then you can test whether the version 2 like creates clusters. You can also test whether you can upgrade it from version 1 to version 2. And because we test this, then we know for customers or for users that they have a very easy life because they can just update it, like he's going to show that later, and then everything works. So we made sure, because we tested these cluster stacks, these bundles of configuration before, and we also upgrade test them, then we can like perfectly see that in the end it works very well for the users. So that's the fourth step, that you can actually use them. All right, now I described the whole development cycle, and now Ani is going to show you a bit more how to use it and also how to develop it.
Thank you, Yanis. So as a cluster stack development model, we have mostly two interactions, one from user side, one who uses the clusters, and one who manages the applications on the cluster. And the second most part is the developer who builds those clusters, release it so that users can use those things. So first we are going to look into user part. So let's see the using of cluster stacks. So cluster stack is essentially an Kubernetes operator. So how many of you know what's an operator? Okay, so operator in general works in a recycling loop where it fetches the current state from the API server, it tries to match the desired state, and it fixes it so that it manages the desired state always. So as a cluster stack operator, as Yanis says, what we want is to all of the components get ready or like ready for the user always. So as a cluster stack operator, it basically does, it creates the whole CAPI environment and builds node images, build everything for you so that you can create your cluster at the end as a user. On the other hand, on a vanilla CAPI environment, you have a whole bunch of CRDs to like custom resources to apply before even you can create your workload cluster, which can be really tough. As it said, like you don't have your like CNI there, or you don't have controller manager there, so you can't create the cluster. So that doesn't make sense for my user. Yeah, so using cluster stacks as a user, you first choose the cluster stacks, you apply the custom resources, then you wait for your management cluster to get ready. Then you have your management cluster ready as the operator side, then you create the cluster at the end and you upgrade it as a user. So there is only one object that you manage for your workload cluster, always. So let's look at how the cluster stack looks like from a CRD perspective. So we have first the provider. So provider can be anything from Docker, AWS, like anything you can define. We have a naming of every cluster stack. Here it's feral, and you have the Kubernetes version, which is running in your management cluster. And the channel basically specifies the channel which from the cluster stacks is going to get downloaded. It can be beta, it can be alpha, anything. Then we have versions, which basically represents multiple instances of the cluster stack. So you can have two cluster stacks, and you can upgrade, like whenever you need, you get the new cluster stacks and you upgrade. And the provider ref is, as some of you have known CAPI, CAPI also have a provider implementations, and they basically connects to each other by a provider ref, and it's basically same. So you have the cluster stacks, and on the other hand, you have cluster stacks provider. And suppose you like cluster stack so much, you build your own provider on top of it. So you write your own provider operators to manage the networking on the provider sites, like all the building node images, like configurations you do in a provider way. So suppose you applied the cluster stack, it is there, management cluster is up. What you want is the final workload cluster. So here is the workload cluster from a CAPI. So if you can see the cluster networks and the worker machine deployments. These are all CAPI naming conventions, which basically represent your worker machines and your worker cluster networking stuff. And from here, the most important thing to look here is the topology cluster classes. So as you can see, the most important part is you always specify the cluster stack which you want in your worker cluster. The name should be like this. Like if you want v2, then you get a v2 there. And the second one is the version, the version you want in your worker cluster. So this is what you are going to apply at the end, like just one CRD for your worker cluster. And suppose you're serving your customers with v1. Now the developer created the v2. So now as a user, you want your cluster to be upgraded to v2. So from a user of cluster stacks, what you need to do is just update the cluster classes and update the version and reapply the CRD again. So as a user, the upgrading your cluster is just by changing the cluster classes and the version at the end. No need to worry about cluster add-on, how you go into your workload cluster, apply those add-ons, and no, everything is done by the operator itself. So you upgraded your cluster. So I'm going to give a live demo now. So we have a management cluster. Let's see the pods. These are the pods for the cluster stack operator and CAPI and all those controller manager are there. Let's see the cluster stack YAML. Yeah, we have the same YAML as our slide. Let's apply the cluster stack now. Yep, cluster stack is applied. Let's get back into the cluster stacks. Let's see what is there. Yep, we have some cluster stack as object, and it's created a cluster stack releases. So your cluster stack releases are ready to get served as a management cluster. So now it's time to get into see the workload cluster. So let's see the cluster object. Yep, it's again the same, very simple. Let's apply it. Yep. So once you apply your cluster object, you see cluster, and as I said, once you apply your cluster object, the workload cluster is going to create it. And what you need your cluster add-ons to get into the workload cluster. So you don't need to even apply the cluster add-on object. So here you can see your machine is being provisioning. So let's wait for it and let's look if there is some cluster add-on object is there. Yeah, we have a cluster add-on. The cluster stack operator manages that. Once you apply a cluster workload cluster, the add-on is going to get created automatically for you. And we have the cluster ref in the spec to reference the workload cluster. And let's wait a bit. Let's see the machines. It's provisioning still. Oh. We got a provider ID from the Docker. Let's get back into the cluster add-on. It's true. The true means your cluster add-on is being applied to the workload cluster. That's it. Now let's get the kubeconfig of the workload cluster. So we get the kubeconfig from cluster cuttle. Let's get to the workload cluster and see what is there. Your kindnet connectivity agent metric server, everything is there. So let's see the kindnet. So in the labels, you can see there is a label cluster stack Docker Federal 127 v1, which represent that this cluster add-on component is associated to the cluster stack, current cluster stack, v1 cluster stack. Now your Docker cluster is serving the user happily. Now you want the second one, v2. Let's get into the management cluster again and update the cluster object. I updated in the VS Code, sorry. Let's wait a bit.
This is the magic happening.
This is the magic happening.
This is what we don't show to you.
Yeah, it's version and everything got updated. You can see that. And let's get back into the manage a workload cluster again. Yeah, cluster add-on is true. Means your cluster add-on should be applied to the workload cluster. Let's get back and see the same kindnet, the spec of it. See, the labels has been updated. So your cluster add-on got updated to the next version. So this is how simple from a user's perspective to use the CAPI with the cluster stacks.
You can, of course, install anything you want, and you don't have to install whichever we just showed to you.
So you have happy users. Now we want to develop the cluster stacks. So to develop cluster stacks, we have configurations from a developer's perspective. So from a configuration perspective, there are mostly three components: cluster add-on, cluster classes, and node images, which is typically consist in a CAPI cluster. So our cluster stack configuration looks like in a cluster add-on directory, we have different clustering components, which is here basically a bunch of Helm charts. On the cluster classes are a single Helm charts, which contains the configuration for the cluster API cluster class things. And second one is provide a different dependent node images, which is very obvious. You have different AWS and everyone has a different perspective of building node images. So it is provided dependent. So how many of you would like to manage the Helm version in each Helm charts? That would be like a really good job to do, right? But it's not. That's why our cluster stack configuration is version independent. So you don't manage those configuration versions by yourself. So that's why we created a CLI called cscuttle, which inject the version from outside to your configurations when you update it. So as a developer, you run this command and get the next cluster stack ready to get release. So you create and you see the release assets. You have V2 ready to serve your user. Features of cluster stacks. One example is a multi-stage. As we know, each cluster add-on is a specific component, and each component Kubernetes has had their different requirements. For example, here, as a developer, you can be sure that what you want in your upgrade process. You want a V1 to V2. Now, suppose you want the CNI to be applied first. That everyone understands. So, these are the stages, we call it. And you stages, you specify the actions you want in your upgrade process. So here we apply the CNI first. Then the CNI got applied. Yeah, let's see. And second one is, suppose a lot of people know your metric server might require your connectivity edging to get applied first. Otherwise, it breaks. So your each stage of cluster add-on can wait for each other. So we achieve this by this condition, which is a cell expression. And your each cluster add-on components can wait for each other for their good operation qualities. So for example, here metric server is waiting until connectivity agent has 2 replicas up. So then only it will wait and it's get applied. So in summary, it says structure-wise, this is a very good implementation of usage of cluster API. Like as you can see from a user's perspective, it has a very good experience as you don't have to think about your upgrading clusters, using clusters. Everything is managed in a declarative way and also the operators helps you achieve your goals. And it's very flexible. You can have as many components in your cluster add-on and have your workload cluster ready to serve the users, and with very minimal interaction of like whole bunch of custom resources. Yeah, do you want to there is slides have the link to the cluster stack operator. You can go there. If you find some issues, we will have help to build. Yeah, it's time for any questions. Thank you for listening, and thank you, KCD.
Thank you very much. I saw a question already. So pretty much you can do anything what you want because kind of the node images are part of like the provider implementation that you need to have. Because they might depend on the provider. So, for example, we at our company, we focus a lot on the provider Hetzner, and there we build our node images with Packer, so HashiCorp Packer. Yeah. And then you can, that's actually a good question because kind of you saw the CLI tool that we had there. The CLI tool actually can be extended also to build your node images. So you have kind of a plugin mechanism so that you can just kind of use the CLI tool to do whatever you need to do in order to build your node images. So for example, to trigger like a packer command. Yeah, then you can kind of, you have the whole developing cycle covered there. And then for Hetzner, again, a good example, you need to upload your node images for every user in their project. So every user has a separate project, and the node images need to be there as snapshots available. So you have like kind of this process of uploading them, which can be like then also implemented in the operator in the kind of software. And then like the users just have like certain cluster stacks available in certain versions and kind of can create their clusters directly, and their node images are already there for them, kind of like without them doing anything.
Also, in image builder repository, if you see, you also have provider dependent configurations in the repository. So node images are always provider dependent.
Are there any provider limitations?
Like one of the, the question was whether there are any provider limitations. There is like one limitation if you want, but like also not really. We use the cluster API, so you need to have a cluster API provider integration. And then you can like, if you want to, you should probably, but if you want to do the node images as well, then you need to have like a way smaller provider integration also for the cluster stack operator. It's like you cannot compare it with what you do for CAPI. It's like way simpler. But then kind of you need these two provider integrations and then you can use any provider. Any other? Yeah, sorry.
Hey, hi. Can you hear me?
Yeah.
Yeah. Hey, thanks for the talk. I was curious about this one thing which you mentioned on the slide where the add-ons CRD has this specification for before cluster upgrade spec, right? So it seems like you are trying to manage the state of the add-ons and manage it in a declarative fashion where it goes in a certain sequence. So I'm just curious why did you explore other options like where I think Argo gives you the opportunity to have sync waves or something similar? So I was just curious what were the challenges if you went in that direction, or why did you go in the specific direction of preserving state in this way where the operator takes care of installation of the add-ons?
Yeah, it's also a very good question. Kind of what we do, like I showed you the slide at the beginning. It's like you need to solve a lot of tasks. And you can solve these tasks in a lot of different ways. So it's like there's no right or wrong there. Also, like whatever we do there, you can do it manually. You can do it to some degree, or to like everything with other projects. It's like I'm not going to say that you cannot do it in any other way. Like, why did we do it this way? We do it this way to have everything in one place. Kind of, if you manage this with Argo, then you need to kind of manage Argo in the whole lifecycle, what we have there. And that obviously also creates an overhead again. So like we chose to kind of put everything, like control everything ourselves, or like most of it. And like in this way, it's like very lean. Like we could also, like Sweltos is another project that manages potentially cluster add-ons, but like which also has to be managed itself. So that's kind of why we chose to build our own solution there.
Hey, thanks for taking that. Just to add on to that question, I was curious about, so when the add-ons do get installed, so which means that the CRD is now managing the state of these add-ons. So in case if I would want to maybe, for example, upgrade these add-ons on the cluster live, or maybe create a new release for these add-ons for the next version, maybe for the new cluster which is coming up, how Are you tackling it right now, or is this something which you folks have?
Yeah, that's also a very good question, and like there is also a lack, I think, in existing projects. Kind of we bundle it together in these cluster stacks. Then you release the whole thing. So you might upgrade something in your node images. You might do like an upgrade of a Kubernetes patch version, and then like you might also upgrade your cluster add-ons, and then you upgrade the whole thing, and then everything gets like automatically done by the user. I think the time is over, so I think there were more questions, but I'm not sure if we have time for that, or should we do it like in private? I don't see anyone coming in, at least.
I'll just do a real quick yes or no questions. Are the cluster add-ons like user configurable, or are they static within a stack? Like can the
they are
user deploying the cluster choose which add-ons to use?
So they are like static in what we do, but then it's the question how we like do it in a way that you can configure it as well. But like in the stack, they are static.
So if like you would want to provide different configurations to end users, you would have to provide several stacks to them.
That is true. Yes, definitely. Okay. Yeah.
But you don't manage the versions.
Yeah, no, but that's a very good question. So if you want to have kind of like a different configuration, like in the one you use Cilium as CNI and the other one you want to use Calico, then you would create a different stack in order to again make sure that like the whole stack works together, can be upgraded, etc. Yeah.
Yep.
All right. Thank you very much.
Thank you very
also
much.
for the questions.